Hello everybody, I am Dr. Aziz Arbai from Morocco, and I present my work 3 matrix calculation of the n power and the exponential. This work explores a robust method for calculating the nth power and the exponential of 3 matrix without resorting to diagonalization, whether it is diagonalizable or not, whether it has two distinct eigenvalues or not, and whether these eigenvalues are real or not. This approach significantly simplifies complex matrix operations. First, the power of matrix of order 3. Proposition: for every A matrix 3, we have this relation, the 3 power of A, because since the Cayley-Hamilton theorem, because we have always PA equal to 0. So the n power of A also is combination of 2 power of A and I. Calculation of coefficient. The coefficient is we have to determine AN, BN and CN. We have this system of recurrence, so we can transform it in this system, this recurrence. We use matrix B. So we have this relation always of is the same of AN, CN and BN. Using first and 2 and 3, we have the fourth relation, and we use this method to resolve the recurrence equation. So we have this equation of R with R in C is complex. So let alpha 1, alpha 2 and alpha 3 the solution of the equation E. So also if alpha 1, alpha 2 and alpha 3 are eigenvalue of the matrix E, and UN. So first case, if alpha 1, alpha 2, alpha 3 are different 2 by 2, so UN have following formula with C1, C2, C3 constant, such we have U1, U2, U1. So we can determine C1, C2, C3 as below. With this matrix is Vanderman matrix. It is always invertible matrix because it is determined have this formula, and the alpha is different 2 by 2. So C1, C2, C3 is the inverse of the Vanderbilt matrix for multiplied by this vector. U1, U1, U2, U3 are the vector of the canonical basis, and finally, after we calculate the inverse of the Vanderbilt matrix, we have UN as follow. And the n power of A have this follow formula. Second case, if alpha 1 and we have alpha 2, alpha 3 in R real, and alpha 1 different to alpha 2. So UN have this form, and we do the same as first case. We determine the constant C1, C2, C3. Now the matrix is different, is like that. We have to calculate the inverse. This matrix is invertible because the determinant have this form. Here is the inverse of this matrix. So the constants have this form, and UN, finally UN have this formula, and AN, BN, CN also have this formula. We generalize here AN, BN, CN, and the power n power of A finally have this, verify this relation. The third case, if all the eigenvalues are equal, and of course they are real because the equation is equation of order 3, and it has always a real solution, almost 1. So PI keys have this form, and UN is following. And now the matrix is different, like this. This matrix have the determinant depending of alpha. So there are those two cases. The first is simple, if alpha were 0, so AQ, the third power of A is 0, and if alpha different 0, firstly the matrix is invertible, and we calculate his inverse. It's as follow, and UN have this formula, and AN, BN directly we obtain AN, BN, and the n power of A is like that, and simply have this formula with alpha is E in 3. The exponential of a matrix or matrix exponential, we use the n power of the matrix, because if n power of matrix A have this formula, the exponential of matrix A always have this formula, depending just of the power 2 of A and I. First case, if alpha 1, alpha 2 and alpha 3 are different 2 by 2, in this case we have seen that n power of A is like that. So to calculate the exponential, we have exponential, you have always this formula. So we calculate. There are two cases. If all the alpha E different 0, so we have the exponential of A have this formula, and if there exists K such alpha K equal à 0, like alpha 1 equal à 0, so you can have this formula, and An, the n power A, have this formula we have seen before, after, before, and the before and after exponential A have this form. We use the n power of A. A second case, if alpha 2 equal alpha 3 and alpha 1 different alpha 2. So we have seen that the n power of A verify this relation. So we have the same exponential verify this relation, and if alpha 2 equal à 0, we have this formula of An, and the exponential, it's simply like this. Third case, if the 3 alpha equal n power of A is like that, and alpha is equal A instead of 3, and the exponential of A have this formula. So, thank you and see you later.